Bismillah ar-Rahman ar-Rahim. My dear students at Rital International Academy, 11th grade, regarding your final exam, it would be a few days, we will revise some questions regarding the final exam. So please try to study this video and you will be okay. This is a question. A moving electron is deflected by two oppositely charged parallel plates, as shown in the diagram below. We have an electron here. We're launching this electron until it will reach this parallel plates. So we know parallel plates. What do we mean by that? We have a positive direction and negative direction. So the electric field between the plates is directed from A to B, A to B, B from B to A, from B to A, or C from C to D, from C to D, or from D to C here. So let us try to understand exactly what do we know about this question. At first, you have to know that electric field is always from positive plate to the negative plate, positive plate to the negative plate. And you have to know that like charge repel, unlike charge attract. So we have electron with negative charge. We have an electron with negative charge. So what do you expect? It will attract to the positive plate. Attract with positive. And it will repel with negative. So from A to B, here you have to know a vertical point on a charge does not affect at all to the direction of charge. We have A and B, it's a vertical, so it won't affect from A to B or from B to A. This is always affect when it's perpendicular to the charge. So if we have a charge here, it should be from up to bottom or from bottom to up. But from left to right, right to left, it won't affect at all on it. So we could cancel option A and option B. So we know that we have a negative charge, so it should repel with negative plate and attract to the positive. So it is go this direction. We know that like charge repel and like charge attract. So we have to know from this point this is a positive plate, this is a negative plate, because we know that electric field is always from positive to negative, so this is its direction. This is its direction. Let us look at this simulation. We have this negative charge. We have positive to a negative. You have to expect the direction of the electron. So it will go to this direction. It's repel from negative, attract to the positive. So let's take this movement. Let's take this direction. So this is what we have seen at the previous simulation. So the right answer is from C to D. It won't be from D to C, because if it's from D to C, that means D is positive. Positive should attract electrons charge. That does not happen at all. Second question, we have this. An electrostatic force of 20 newtons is exerted on a charge of 8 times 10 to the negative 2 coulomb at point P in an electric field. The magnitude of the electric field intensity at P is. Here it is an easy question. I won't give it as a multiple choice. I will give it as if you know the equations, you have to replace the variable on it and you will get the right answer directly. So here you have to know electric field E, it stands for electric field, equal force over charge. So equal force over charge. You know force is 20 newtons. This is force. Charge is 8 times 10 to the negative 2 coulomb. So rightly replace them 20 newton over 8 times 10 to the negative 2. 20 over 8, you could cancel it by divide each side by 2. You will get 10 over 4 by 2 again. You will get 5 over 2. 5 over 2 equal 2.5. 2.5. 2.5. 10 to the negative 2, if it should go up, here you have to know this mathematics, become 10 to the 2 when it's go up. And now you could get this answer 250 Newton per coulomb. Or you will keep it in this way based on the options you got. If it's a multiple choice question, you have to know how to deal with each one of them, this way or this way. 2 0 1 0 cancel the decimal, and the other 0 come here, so become 250 Newton per coulomb. Here, the diagram below, which represent an electron being projected between two oppositely charged parallel plates. As the electron moves through the electric field, the magnitude of the electric force on the electron, be aware to this word, to the electron. It will decrease, it will increase, or it will remain the same. That doesn't mean they are an answer. Here, you have to know that it is force, which is mean it is a Newton over Coulomb. This is an electric field. Newton over Coulomb. Since we have same amount of charge at electron charge, 1.6 times 10 to the negative 19 Coulomb. So it's remain the same here. It's remain the same. That means the force to remain the same. So since they both does not change the electron charge, it will remain 1.6 times 10 to the negative 19, either here, or here. So it's remain constant. Newton is remain constant as well. Force remain constant. That means the right answer is C. So when we launch a charge through a parallel plate for electric field, we have to know that electric force does not change at all, even if it is a negative charge or a positive charge. It will remain the same always. Another question we have here, compared to insulator. Insulator, it is metal does not allow any charge to pass through, or it's allowed for a tiny amount of charge to pass through. It's not always prevent charge to pass through. Metals are better conductors of electricity. Why metals are better conductors of electricity comparing to insulator? Because metals contain more free, which of the following: positive ion, electrons, protons, or negative ions? Here I should put ions. Okay, here from the basic point of view, you have to know that which one of these four are responsible for carrying electric charge, how electric charge flow through metals. So you have to know that it's not a positive ion. Positive ion does not happen here. Either ion A or at D, they both are wrong. We have to cancel them. We have electrons and protons. Protons always at the middle, does not go out. So which one of them? It is an electrons. Electrons is responsible for carrying charge from point to another point. So I could tell that easily. It's based on free electrons. At metals, we have more free electrons comparing to insulator. That's why we choose metals to be a charge carrier, like copper, like aluminum, like iron. But we are not choose any insulator at all to be a charge carrier. So it's based on free electrons. How much electrical energy is required to move 4 micro-coulomb charge through a potential difference of 36 volts? Here, you should know the equations and substitute directly to the equations. If you know it, you will get the answer easily. Okay, volt is work over charge. Volt is work over charge. So I have a charge, I have the volt, I need the work. Be careful. 36 volt equal work over 4 times 10 to the negative 6 coulomb. Now cross multiplication between both of them. Cross multiplication here. 36 times 4, you could write it over 1. 1 times work, it would be work equal 36 times 4, 144 times 10 to the negative 6, and it's become joule. None of this, it is our answer. Okay, you have to know how to manipulate on the answer. So I have here 10 to the negative 6. I could write it this way on scientific form. I could put a decimal here, 1.44. So I cancel two zeros, 1 and 2. So it's become 10 to the negative 4, the right answer here. Let's see. This is the right answer. I hope you all understand what I gave it to you. Try to study from this video. I will upload another video, another 2 videos regarding the final exam. Good luck you all. Thank you.